This is question 8 of civil engineering paper of GATE 2018 afternoon session. A flow net below a dam consists of 24 equipotential drops and 7 flow channels. The difference between the upstream and downstream water level is 6 meter. The length of the flow line adjacent to the toe of the dam at exit is 1 meter. The specific gravity and void ratio of the soil below the dam are 2.70 and 0.70 respectively. The factor of safety against piping is. So, in this question, the flow net related data, that is the number of equipotential drop and flow channels, are given for a seepage condition below a dam. The difference between the upstream and downstream water level is also given as 6 meter. The length of the flow line at the toe of the dam at exit is given as 1 meter, and the soil property, that is a specific gravity and void ratio of the soil below the dam, are given as 2.7 and 0.7 respectively. Now we need to calculate the factor of safety against piping. So this question is from the topic of quicksand condition. You may study about quicksand condition and flow net in details in lecture 11, permeability and seepage, soil mechanics, geotechnical engineering 1 by Professor Dilip Kumar Vaid, IIT Kharagpur. So the factor of safety against piping, we may write the factor of safety against piping is equal to the critical hydraulic gradient divided by exit gradient Now so the factor of safety against piping is defined as the ratio of critical hydraulic gradient to the exit gradient. So now we know how to calculate the critical hydraulic gradient. Critical hydraulic gradient, that is IC, that is, you know the formula for IC is equal to G minus 1 divided by 1 plus E, where G is the specific gravity of soil and E is the void ratio. Now in this question the value of G is given as 2.7 minus 1 divided by 1 plus E, that is the void ratio, is given as 0.7. So it will be 1.7 divided by 1.7. So the value of IC comes as 1. Now exit gradient. So exit gradient, the formula for exit gradient. So exit gradient is defined from the flow net. As you can see, this is the flow net diagram for a seepage below a structure. So in the upstream side you can see the head is available. So due to seepage below this structure, a flow net can be drawn. So with the help of this flow net we can find the exit gradient. So exit gradient is equal to the head available at the toe of the dam, that is head available at the toe of the dam divided by length of this flow channel. So here the head available at the toe of the dam can be calculated as the total head available, or you can say the head difference between upstream to downstream divided by number of equipotential drops. So here you can see the head difference between upstream and downstream is given as 6 meter, and the number of equipotential drop is 24. So you can write the head available is 6 divided by 24 at the toe, and length of this flow line at the toe or at the exit. So the length of the flow line is also given as 1 meter. So this will be 1. So this will be 1 meter. So it will be 1 by 4. So now putting the value of this critical hydraulic gradient and exit gradient in this equation, we can find the factor of safety. So critical hydraulic gradient comes as 1 divided by exit gradient. So exit gradient just we have calculated as 1 by 4. So the factor of safety comes as 4. So we can say the factor of safety against piping is 4. 4 is in option D. So option D is the correct answer for this question. Thank you.